Hello everyone, welcome back to my channel. So in today's video, we are breaking down one of the most misunderstood topics in Kubernetes, pod scaling with the right sizing of their requirement as per your workload. If you have ever wondered why your pod overconsume CPU, why clusters stay underutilized, or maybe how auto scaling actually works behind the scene, then this is the video for you. You have landed at the right place. So let's get started. So in Kubernetes, every application needs the right amount of CPU and memory to run efficiently. But the truth is different. The truth is, most clusters are either over provisioned or under provisioned. Over provisioning leads to wasted resources and high cloud bills if you are running your cluster inside any public cloud. And under provisioning leads to a pod crashes, throttling, or maybe a poor performance of your application, right? So that's what the main two thing. So let me just make a note: over provisioning and under provisioning. So that's what the problem is so far we have seen. So how to deal with it, right? So before we start or before we jump into to overcome these two problems where we will define the auto scaling, we just need to understand two more important concepts which we have already discussed in one of the previous video, but let me put it one more time. So we have, or maybe we can define a request and limit in our Kubernetes manifest file, right? That pod manifest file when you are writing down. The request will make sure that guaranteed minimum of CPU or memory, whatever that you are getting, right? That you will definitely get. So this is the guaranteed CPU and memory, because whenever you are starting your pod, so it will gonna request, okay, hey, I need this much of CPU and memory to start my application or to start myself. So that is the guaranteed for your request. But limit is something that over time, if your application is getting heavy, or maybe it is start consuming more resources, right? So you need to put a full stop somewhere, right? So that is that limit is, which can say that, okay, max resource a pod can consume. So these thing we have already defined, right? Or maybe we have already discussed, because Kubernetes schedules pod based on request, not on limits, right? Limit is something that you can just put some kind of restrictions, but the schedulation will work on the basis of request. If your requests are too high, right? Let's say that you have, we are saying that guaranteed you will work, right? But what if your request is too high and that much of resource is not available in the node? What will happen, that your pod will get stay in pending state. If your requests are too low, that means that maybe your app can landed in the performance issue again. It is throttling down, slow down, right? Because that maybe your application needs more request, but you are not giving that much of resources, right? So in order to overcome this, we have two concept, is something called horizontal and vertical. So there are two concern. These are the normal concern, as we have already discussed, or maybe you have already seen in some other aspects also, like what horizontal is, what vertical is, right? Let's take one by one. So horizontal is something like adding more you can say that nodes, or maybe you can say the pods with same resources, or maybe same number of resources, or maybe types of resources, where you have that, let's say, uh, memory use consumption, or maybe you have that GPU types of CPU or motherboard. So that way you can define. Vertical is something where we can, or we add high number of CPU and memory. So this is in terms of whether you are working in the cloud, whether you are working in the Kubernetes cluster or anywhere, right? Horizontally is something that you are adding a more nodes or maybe more pods in terms of Kubernetes with the same resources. Let's say you have that node is running 2 CPU with 4 GB of RAM. You can add that one more. So in this way, you are extending your cluster in a horizontal scale. Vertical is something on the same resource, same node, or maybe same port, you are just increasing the number of CPUs or the size of the memory. That's what you are doing. So that way that you are vertically uh, expanding your cluster. So let's come to our nodes. So auto scaling in Kubernetes, we have only two auto scaling. One is called the HPA, which is nothing, horizontal pod auto scaling. The other one is VPA, which is a vertical pod auto scaling. Usually we have two scenarios that we have already discussed, right? One for cluster infra, and the other one is running on the inside your cluster, well, that you are running, right? If you're scaling your cluster infra, that what you horizontal scale, what you can do, you can add more node in the cluster. Whereas for the vertical scale, if you are doing, what you can do, adding more resources like CPU and RAM in a same node. That's what that vertical node. Whereas scaling workload means the pod itself you are scaling inside your cluster. Horizontal scaling is adding more pods and for same application. And vertical scaling is adding more resources to the allocated resource uh, to a single pod, right? That's what we have seen. So in order to achieve this, there are two methods. We have understood, we have HPA, we have VPA, right? We both operation can be performed on your infra, which is your cluster, and both can be performed on your workload, which is running inside your cluster. Let's say your application is running in a pod, right? So a pod can be horizontally and a vertically auto scale. But how to do that? We have two methods, right? One is the manual, and the another one is automation, like auto scaling. So that's what that topic is, right? Let's try to understand what manual method is. So let's come to our notes. So for infra, generally what we do is we create another node, right? If you have your on-premises cluster where you are running, right, you can create one more node and you can simply join that to your cluster. So now what you are doing is, as of now, let's say you have two node cluster and you have added one more. Now you have three node cluster. So what exactly you have done is you have horizontally expanded your cluster. Whereas vertically, if you need to do, what you need to do is you need to add more resources in terms of CPU, memory, or maybe disk like that. What you are need to do is you need to take down that server, and then because you need a restart, right? So this is something that hardly you will see in the production grade environment, where a particular infra is getting expanded as a vertically. Why? Because in this way, let's say you have that number of pods running on that one node where you want to add more CPU and resources. But in order to do that, what you need to do is you need to migrate all those pods. You need to migrate all those pods from this node to another healthy node, and then you can bring this node down, perform your operation, make it up, and then again balance your pods across these nodes. So it's a kind, technically it is possible, but it is very rare that you will find in the production grade environment. Maybe in uh, development or maybe any kind of test environment you can perform, right? So they will do it kind of the horizontal stuff. Whereas for the manual workload, which we have already seen, right, horizontally, if you need to do, simply you can scale your replica. You can just say cubes, ctl scale deployment, then you just need to expand the replica dash replicas, and you can give. Earlier, let's say it was running with 2, and now you have scaled it to 5. So what will happen is, with the same resources, with the same configuration, another 3 nodes will be added to this application. So now what we have done is, we have horizontally scaled our deployment. Whereas if you do for the vertical, we have already seen that add it you can do, right, and you can expand that resources whatever they already allocated. Although there are some restrictions while doing or maybe editing that particular deployment in terms of CPU and RAM, that we will discuss in later. So this was the manual method, right? You can just cube join, taking down that one of the server, scale that replica, or maybe added the current deployment. For the automated part, for the infra level, we have something called cluster autoscaler. Let's say you have number of nodes, right? You have distributed number of nodes where you have, let's say, GPU based node, where you have memory optimized, where you have some disk optimized, like that you have done, right? You just create a node group, and slowly and steady, one by one, you can do that. There are another tool also available in the market which you can get the leverage to automate your cluster, but this is the cluster autoscaler which we just discussed. Our focus will be more on this workload part, which will be a horizontal pod autoscaler and vertical pod autoscaler. So these are two different entity, different object in your Kubernetes cluster. So how we can define that, right? So let's see. HPA is nothing. It's a controller that automatically scale the number of pods in deployment. We have already discussed, right? When you do that scale deployment, obviously there is a controller which will keep and track, okay, how many replicas are requested, and based on that it will scale your number of pods. It will work in the deployment, replica set, or maybe stateful set, based on the real time resources uses like CPU, memory, or maybe a custom resources. That thing was the manual, but now we are talking about the automation, auto scaler, automatic. It is getting scaled as per the, because it needs something, right? It is not something in the air or maybe a black magic, like okay, whenever it desire, okay, it get extended. No, there is something checkpoint. There is some checkpoint which HPA can consider, okay, now this is the time I need to scale that particular pod. That's where this resource usage comes in picture. You need to make sure that you need to set some kind of your threshold, like if that much of CPU is consumed, you need to take an action. So in it can be CPU, memory, or the custom metrics, right? This is not something that you can do it for only a resource inside your cluster. No, you can set some another external logging mechanism. Let's say you are Prometheus, you are getting some logs and you want to expand those logs inside your cluster. So what you can do, you can get those, and you can define that external API which will convert the Prometheus logs to Kubernetes understandable logs, and based on that it can do all this HPA and VPA action, which is nothing a horizontal and vertical autoscaling, right? How it works, let's discuss that. You define a target metric, let's say keep an average of 50%. The HPA continuously monitoring the metrics via the metrics server. This is the requirement for the HPA and VPA to work, because on these terms, right? So in order to get the live CPU and memory consumption, obviously we need to have some metric server which can take current usage and pass it to HPA. So we need to deploy this inside our environment. So we are gonna using the same metric server which we discussed earlier in this course, and we will see that how HPA can continuously monitoring those matrices, and if a threshold reaches to 50%, whether it is adding another pod or not, to balance that your performance and keep your CPU uses under 50%. When a usage goes high, right, it or below the target, it increase and decrease. Yeah, that's what we have already discussed. Requirement is only you just need to have that service. This metric server needs to be in place. If you are doing it with the imperative, right, like from the command node, if you are, you can do, right, just whatever the deployment you want to make sure that to be managed as a horizontal pod autoscaler, you can just run this command kubectl autoscale deployment, give that deployment name, and sets the threshold value for the CPU percentage, and what are the minimum number of replica at a given point of time can run if CPU is less than 50, and if it is more than 50, then how much it can scale up to. It can scale up to 10 replicas, and then you can verify that whether your HPA is there or not, right? So that was the HPA. Before we jump into the VPA, let's finish the demo for the HPA. So what I have done is I have gone ahead and I have already deployed this metric server just to save our time. Let me show you. So this is the same cluster which we were using since beginning of this course. Although it is on version 1.30.14, but yeah, there is one of the topic which we will see that how you can upgrade your cluster. Okay, so now let's focus on our today's topic. So yeah, I was just showing you that we have this something called metric server is up and running since this much, right? That is the first requirement we have understood. Now we need to deploy this HPA app demo. Let me show you. So here we are doing nothing. We are just creating one deployment called HPA app, which is gonna using a Nginx image. I think this image will not work. I have tried it, but it was not working. So let me fix it. Nginx image, and it will gonna request 100 sorry, it will gonna request for 100 milliseconds of CPU, and it can limit up to a 500 milliseconds of CPU, and the same deployment then we are exposing as a service called HPA SVC. That's what we are doing here. And under the HPA config, right, now what we need to do is we have this imperative command which we just discussed, right? But what if we want to make it as a declarative, if we want to make it as a manifest file? So how you can define that? You can define that something called autoscaling v2 and horizontal pod autoscaler is the kind. This is the metadata and specification. What you need to do is you need to target, right, because here you are saying that deployment, right? So this part you need to define. Okay, on which deployment you want to make this HPA applicable. So here what I am saying is API version equal to this one deployment, and this is the name of the deployment which we just discussed. Then I am defining that minimum number of replicas and maximum number of replicas. Then the metrics I am defining, because that is the most important thing, that okay, on what basis you are doing. So I'm saying the type will be the resource, and which resource you can define many of the resources. So here I'm just defining only the CPU, and if it is the utilization is kind of average utilization for all replicas, whatever you are defining, is more than 50, then it should take an action and add one more pod inside your cluster, right? And this is something the behavior, because I by default it is a 5 minutes, which can see a stability in your environment, and then it will gonna do that particular stuff. But what we need to do is we can just set it to a 30 seconds, just to show you in this demo like how exactly it works. So what I have done is I have set the behavior of the HA scale down is to 30 seconds, so that it can quickly monitor if this CPU utilization is less than 50, then it will gonna scale down your pods. Okay, so that was the HPA configuration manifest file. Let's quickly deploy this. I will go inside our labs, and here we have file. Just let me see. I think it was, yeah, just let me quickly finish this to Nginx. And let's quickly create hyphen f 67 hyphen 1. Okay, now if you see, we have this deployment in place, HPA app, and we have one of the either it one only, let me see, yeah, it was only one. Okay, so it was up and running. Now we need to deploy this HPA config file, and then we'll need to see that, okay, what is this average CPU utilization for your particular deployment, and if it is more than 50, then let's see whether it will gonna add another pod or not. Okay, so let's quickly create a HPA config, and if you see now, you have this HPA which is referencing this deployment, and this is the CPU. Maybe we just deployed, right? So probably it will show you in some time like what is the current. But if you want to see, so we have our metric servers in place. As of now, there is nothing happening on that node. So you can see it is saying a 0% is usage, and you have put a restriction or maybe threshold up to 50%. These are the requirement. As of now, only one replica is running, and these are all the detail. If you want to see more detail, you can just simply describe this as we do always for other resources, which will show you another thing. Here you can see these are some metadata. This is the minimum max behavior. You can scale up Windows 0 second, select policies maximum. These are the policies. Scale down policy, you can see that we have set it up to 30 seconds, right? And this is some events which is already happening. So what I will do is I will just generate some false load on this app, and then we'll see how HPA will come in action, because as of now it is 0% only, right? So what I will do is you can use any of the this command, right? It is just to generate some false load on your particular deployment. You can just run in one of the window this busybox image based container, and you can just run this while, because what I need to do is I just need to hit this service, because we have exposed this, so that CPU will get triggered. Or you can do in one line, or maybe you can do it in background. So what I will do is I will gonna run few in background, so that it will just generate some load. So we have two ports up and running. One is already running, and the another one is already also running. Right now, if I just go and see the usage, it is still 0. But in meanwhile, if you see, it will come up. Now you can see it is 11%, but we have limit of 50%, so we need to wait until it reaches to 50%, and then it will give it to you this much load. It's 38 now, because that requirement is now getting increased. What we can do is, let's do one thing. Let's edit this percentage, the threshold I am talking about, the average utilization. Let it make it 15%, so that we will see it is done now. And you can see that it is 37, it reaches 37, but now I have a new limit is 15%. So it will check, and then quickly it will go you it will quickly create. Let me just take one more session. I just want to show you that how quickly it can create your you can see it has already scaled your two replicas. Can you see now? Let's check k get pods, and here you can see that, right? It has already scheduled, and now you can see that the CPU utilization is also getting balanced, but it is still beyond 15%. It is saying that 18%, right? Now it is came up to 14. But it doesn't mean that it is, if it is 14%, then it will quickly bring it down. No. Again, it will check for that particular scale down behavior which we have set up to 30 seconds. If it is up to 30 seconds, right, then probably it will go down. So that's how that you can just put your application on. If your application is like kind of expecting some unpredictable workload, if you are getting a spikes on some defined window or something, right, you don't need to worry. You can hand over your application, your deployment to your HPA configuration, which is horizontal pod autoscaler, and based on the requirement, based on the CPU utilization, what will happen is your deployment, your pods, your replica will get expanded according to your configuration, and your performance will be balanced. Because here you can see that with the one replica, the CPU utilization was 33. Obviously, we'll get some kind of low performance. But when we added a 3%, the moment we add a 3 replica, what will happen is the CPU utilization goes down. Why? Because it balanced the workload. Now we have 18, 14. You can see that gradually it is coming down, right? And then it is coming all this stuff. So now what I will do is, I will quickly delete this load generator, one of the load generator, to, and you can see we have only one. And now we'll see how much of CPU utilization is there, and based on that, that it will expand your workload and it can decrease your workload. But yeah, it will gonna check your what it will gonna check you the stability of your workload, whether you have that or not, and based on that it will just do that stuff and will give you a pod, right? So that was the horizontal pod autoscaler. Let it run. Meanwhile, what we will do is, we will gonna discuss something called vertical pod autoscaler, right? Let's go back to our notes, and we will delete it, but we will see that how it can do. That's what we have. Scale up happens quickly or within 15 seconds. Scale down happens slowly only after 5 minutes of sustained low CPU. That's what I have mentioned, right? The moment after 5 minutes, if it find okay, there is nothing worrying about the CPU, what will happen is it will gonna scale down your replica. And this is right. HPA depends on the metric servers continuously watching the metrics defined. It can also get the information from the custom metrics adapter inside the workload and from outside source using external adapter like database, Dynatrace, or maybe if you are running inside your deployment as well or inside your cluster like say Prometheus, that also it can get. Now let's see the VPA, right? So we just need to understand one thing before we jump into the VPA, right? What we need to do is, as far as what we have seen is, we can edit the current pod usage and something, but you cannot change the resource request and limit, right? I mean, you can change inside that file, but that file will get saved as a temporary file, right? And then we need to replace our deployment using that new temporary file, which actually deletes your current pod and deploy a new pod with this new resource and limits information, right? That's what we have seen. But it that require a restart of pod means pod needs to be terminated, and then it will redeploy it from the temporary saved file, replace forcefully with the file which is again deleting the current pod, and start it again with the new resource limit. That's what we just, that is a default behavior, and they call it in place pod resizing. That's what we have already seen, right? If we want to take leverage of in-place pod resizing without recreating it, then what we can do, we can enable a feature gate called what? We can enable this in-place vertical scaling equal to true, because by default it is not there. We have a two demo for the VPA. One is without this. We will see the behavior of the VPA, because VPA we have discussed that we need to add more resources inside a cluster pod, right? And that requires a reboot. Reboot means uh, recreate of your pod. It will gonna terminate the current one or the old one, and then it will deploy a new pod from that particular file. But if you don't want that behavior, you want that your resources will get changed on fly. So that is the thing we can do. Yeah, that's possible as of now in place pod vertical scaling. But before that, we need to understand the normal vertical pod auto scaling. We have few policies which will gonna discuss this. This is the feature I was talking about in place, how you can enable it and you can get it done. But let me show you. Yeah, these are the some, but this flag we have some limitation that we will discuss later. But now we'll see the horizontal and vertical pod auto scaling. If you are doing a HPA, right, what it can do is it can scale the number of pod, adjust replica like 1, 2, and whatever that replica you need. Vertical is something scales resources of pod like CPU, memory per pod, it will gonna increase. In place scaling is something updates resources in running pod. No restart or downtime is required. And to make it happen, what we need to do is we need to enable this gate feature gate is in place pod vertical scaling. I'll show you how you can enable it and then how you can make it happen. Right? But by default, VPA is not there. You need to install a vertical auto scaler, right? Vertical pod auto scaler inside your cluster. So what I have done is I have cloned this repository, and there we have this vertical pod auto scaler VPA up.sh script, which will help us to create a vertical pod autoscaler. And what it will do is it will gonna deploy few pod inside a cube system namespace, and those pods are admission controller, recommender, and updater. These are few things. Let's see what are those, and then we're gonna deploy our vertical pod autoscaler. So recommender is nothing, as the name suggests, recommend, which is just recommending, right? Continuously monitoring the usage from the metric server for live usage of ports and provide and then recommendation on your CPU and memory values. Updater is something which is responsible to evict the current port if recommender recommend the new values. Let's say now you have the 10 milliseconds of CPU you are using, but your application needs more. Then vertical pod autoscaler predict that okay, you need 25 milliseconds of CPU. Then it gave you a new pod, new values for your resources. So updater, what it will do is it will gonna evict the current pod, and then admission controller is something, a mutation controller basically, while deploying your pod again, because you have done your deployment, right, and it just deleted your pod, then the deployment controller will take lead in this operation, and it will gonna deploy your pod again. But there admission controller will come in picture, and it will gonna mutate, it will gonna modify your request and limit as per the recommender recommendation for this VPA auto pod scaler. That's how it is being done. Okay, we'll see in action now. Let's go back to our cluster. But yeah, just one more thing. Here I mentioned that it evicts the current port, but here we are saying that in place scaling is something no restart or downtime, right? There where a mode is come in picture, there are few modes which we can define inside our VPA configuration, so that basis on that this updater will come in picture, or admission controller will come in picture and takes the action, right? Because let's say you don't want to kill the current process or the current pod, you just want a recommendation for your, maybe you have deployed a new application, right, and you don't want that how that application will gonna behave. So what you can do is you can just deploy that application in one of the what do you call it, that mode is as an initial or maybe off, right, where updater and admission controller will not get active, only the recommender will get active, and basis on your application usage it will just give you a recommendation, but it will not take any actions, right? And how you can do it? For that we have these mode defined is something called recreate. Recreate is something delete the pod and recreate them with the new resource request. That's what we have seen, that we can see that kubectl edit, right? But in this case you don't need to edit, it will automatically adjust that value and recreate your pod. Initial is something sets resources only on the first creation of pod, no restart. It will set that okay, this is the initial stage of your container, then it will sense that usage, and it will just set that particular whatever that you are setting inside your HPA configuration. Post that it will not go and uh, like continuously it will check, but it will not take any action, like it will not take any update or maybe eviction and then recreation of your pod. Whereas off is off, right? No update, no recommendation, nothing. Off is literally off. In place or recreate, which is a new thing, right? It is a new thing, new hybrid mode which will try in place update first. Means you don't need to give any kind of downtime, it will gonna happen on fly. If that is not possible due to some other aspects, maybe your application nature or maybe some other dependency, right? So what it will do is it will gonna recreate that particular port. First it will try to in place update first. All right. So that was the VPA. Now if I'll go back here, you can see that it got terminated. And if you see now, so it is saying you have a CPU percentage less than 15%, which is 11. Minimum is 1, maximum is this one. And let's see how many pods are running now. You can see we have still 2 pods are running. Why? Because this slowdown behavior is a different thing, right? It is a kind of which will check the stability. If it is keep on moving this one, right, then it will do that. But what we can do is we can just quickly create or maybe delete this another pod which is just creating some chaos. Pod load generator dash dash force, and we have only these 2 ports running. Now what will happen is we don't have anything running. This will come down to 0, and once that is 0, it will quickly scale down one of the replica, because we have mentioned that minimum 1 pod of our application is running, right? So that's what this is doing it. Let's just give 1 second and then probably it will give you. Meanwhile, I will just show you our vertical pod autoscaler, how you can do it. Okay, so what I have done is I have cloned this repository. I will update this in this video's description as well, and it is already there in our notes, which is already pushed to our repo. You can clone that. Here, if you go to your vertical autoscaler, so there you can see something called hack, right? And under hack you have something called VPA up.sh. Let's run this, and it will just set some default object which is required for this vertical pod autoscaler to run. You can see that it has done some CRD's definition, cluster role it has done, then it has cluster role binding, and then it is cluster role roles, deployments, something it has done, right? And how you can check that? You can check that k get pods hyphen n cube system. If I just grep for vertical, or maybe it is VPA. Yes. So here you can see that VPA admission controller, it is up and running just 30 seconds before, then the recommender, and then the updater. These are the 3 things which we just discussed, like what is the use case and what is the purpose of these pods, right? Whereas recommender will just keep an eye on the metrics. Based on that, updater will decide whether a pod needs to evict or not. Obviously, you need to set the mode, and basis on the mode also it will take an action. And the admission controller will do a modification while redeploying a pod. Right? That's what that VPA. Here you can see that the moment it reaches to 0, it just deleted that pod. Now you can see we have only 1 pod is running, right? So that was how quickly it can do. But if it is continuously getting some traffic, right, then it will just take more some time to analyze the stability, and based on that it will quickly. But here what we have done is we have set a manual behavior, right, like up to 30 seconds, and it can quickly delete that additional pods. Now, in order to use our resources, what I will do is I will delete this, and as of now nothing is there. Maybe HPA is there. uh, I think that is fine because we are not doing, but anyways, if it is still it will consume some resource, I will gonna delete this as well. Now we are good. We have our vertical pod autoscaler already running. Let's discuss the file now. We have this deployment file, same deployment file, just I have changed the name, and now I am deploying a 2 replica, and it is getting a request up to 10 milliseconds, because we need to see that whether if it is goes beyond that requirement, right, then as per the VPA recommender, whether it will gonna recreate our pod with the new CPU request or not. Then we have this VPA configuration file again, which is from the same auto scaling API, but the kind is vertical pod autoscaler. Then we have this name, the target reference, because now we are targeting our VPA app deployment, and this is the mode I was talking about: recreate, initial, in place request, and off, which we have already discussed. So here you can set that policy. Now this policy we have set, but what is the resource policy, right? Because it is needs to do that. Although it is optional, you can ignore this part if you don't want to set, but better to expand it, because here I'm saying minimum allowed is 20 millisecond and maximum is 200 milliseconds. Based on that, it will gonna take the action on this particular deployment. Okay, now let's come back to our pod, and I just want to update one thing. Come on. This is 2 Nginx. Yeah, that is fine. I just want to change something in this. I want to be, because it can take an action against all ports which is running inside a default namespace. But I want only to be specific a VPA app, right? And if you want, you can delete this. But I will keep it, and let's see how it will gonna behave. Now, first let's deploy our application. Okay, and in the other window, we'll just keep an eye on our ports. So as of now, only one port is up and running. Let the other port come up and then we'll see. As of now, there is nothing, no VPA. If I just say that ports, because it's just deployed, so probably it will come in a few seconds here. The thing here you can see one of the port which was already up and running. We have this one. Okay, why it's not coming up? Maybe it is 10 200. Yeah, it should come. Do we have resource crunch? Let's describe and let's see what is happening with this particular. This is the running one. Non-running one is starting with 2. Okay, insufficient memory, because we have very less memory probably. If I just say k get nodes, k top nodes, sorry. So yeah, it is just reaching almost this one. So probably it is not. Uh, but yeah, anyways, what I will do is I will delete this and will keep on one replica. Okay. Uh, this one, and I will go and I'll just keep one replica instead of two. And let's quickly create it again. Okay, and now let's see what is happening to our pod. It is up and running now. Fine, we are good now. And if we want to see k get no k top pods, it's will come up in few seconds, because metric server needs to analyze the usage of particular thing, right? Now you can see we have 0 milliseconds and it is not going to any VPA action. Moreover, we haven't deployed a VPA as of now. So let's deploy the first. And if I just show you, so here you can see that it is coming as a recreate mode now. What it will do is it will keep on checking that metrics basis on that recommender ports. We have recommender, updater, and admission controller, right? That will keep an eye on all these things. It will keep on running and it should come in a second. Yeah, now you can see it is 25 milliseconds, right? Nothing will gonna happen. Why? Because if you see the requirement, what will happen is VPA app. It is 10. So probably it will recreate it in a second. Why? Because that is something that it is getting beyond that particular requested limit. So in order to do that, because as of now, if you see this describe pod VPA, so it is coming with the request is 10 milliseconds. But our VPA is saying recommending is 25 milliseconds, and it will keep on checking if the usage is beyond that or something. It will recreate this with the new request. So in order to do that, what we will do is I will just hit this load generator command, 883 and 884. Now k get VPA-w. I will keep an eye now. And probably again it is something. Okay, I think we just need to keep one because I have very less memory, I think, on the worker node. I haven't noticed, but let me delete the one of the load generator pod, and then we'll see whether it will keep on running or not. Once this information is increased, then only it will delete this VPA app and it will keep on running that particular thing. Okay, so let's wait. Load generator is not coming up. That's not good. I think it will again cry for that k describe node pod and load generator. Yeah, insufficient memory. Okay, let me do one thing. Let me power off the node 1 and just increase the memory, and then I will come back and we'll see this vertical pod autoscaler in action now. Okay. Okay, I'm back. I have rebooted this with new configuration, and you can see that it again become ready. Let me show you one more time. Yeah, it is ready now. And let's see what is happening to the pod. It's getting created now. It was unknown because that only one node and that was down, so obviously it will not show you, but it should keep coming in a few seconds. Okay, let's see k-top nodes. It's still not running. It's unknown. Let me delete it and we'll create it again. Okay, delete generate one and k maybe cdck lab, and I would say 68-1 and 68-2. Let's delete everything now. Now let's quickly create it from scratch. 68-1, that is done. It should be up and running now. Yeah, it is running now. And let's create this VPA configuration as well, which is 68-2, and it is done now. You can see it's just created this again, 0 seconds. Okay. Now if I just show you the port, so we have only one port running. but I need to run that load generator. Okay, I think we have ran here. Yes, and it will keep on running now. Yes, and let's see the VPN action now. So what we have done is we have mentioned it as a recreate policy and the recommendation is 25, but it's still on running. Let's create one more load generator. I think this time it will not an issue. Command was written right. Yeah, node generate. It was not. There was a typo. This was the typo. Okay, and it should be up and running the load generator too. Okay, it was already there, so we need to change it to 1 because the name is same only, and we cannot have a two resource with the same name. Why it's not getting created? And okay, there is one minus is missing. Sorry about that. Now you can see that load generator was one getting created and it's keep on running. Yeah, now we are good. We'll see the usage for the VPA now, and then we'll see that with the recreate mode, what will happen to this particular pod. Okay, let's just be for 1 minute and probably it will keep on running. It is just 118 seconds ago. The usage was 25 milliseconds. The memory you can see we haven't specified any memory. You can see that we haven't specified any memory, but based on the usage of our application, right, it is recommending you this as well. What it is recommending to this one. Okay, there is a problem now. I'll show you. I'll tell you why we need to delete it again, because what we have done is we have created a VPA SVC, but we are trying to call it HPA VPC. So what we need to do is we need to delete this both pod 1 and 2, and we need to create it again. We have already one pod running. Let me quickly change this to a VPA. I will update this in our notes so that we'll not get confused to doing this. And let's create one more. Now we are good, and we have this container up and running. Now we have three container running. Two are load generator and one is the VPA app which is already running since this time. Now let's quickly see what is the load it will generate. Now it should be up and running. Once that is done, meanwhile, let me see the nodes if it is there or not. Oh man, it was already there. Okay, we could have copied, so it will not get confused. Anyways, you can just follow along with this, and this is the policy which we have discussed. Post that, I will show you that in place upgrade, right? Because as of now, if you just describe this, okay, describe port VPA, you can see it was 10 millisecond, but it has recreated probably. So let me see. Okay, it haven't recreated it. Why it should be VPA 10 only we have requested, right? And with the VPA config we have seen, okay, 20 milliseconds is the minimum allowed, and now we can see it is 49, so it should be created it again. But yeah, again, it will gonna check the usage. It doesn't mean that the moment you reaches and it will quickly create another pod. No, it needs a stability. That's what I was talking about again and again. Once it is reaches to that particular stability, then only it will gonna recreate it again. Okay, it is 49. Meanwhile, I will just show you that the K get VPA, and if I just describe it, so here you can see that it is showing that lower bound, like what is the minimum you need to start your application. That is the target as of now, which we are just consuming. And uncapped target is also there because we are not defining anywhere in this particular VPA configuration. So it is just saying that, and upper bound it is saying that okay, with the current usage, if you keep on running, this is the upper bound limit you will hit. That's what it is saying. And it is why it's not recreating it. That's not good. Maybe it is running with the only one of the replica. Let me just quickly deploy and k edit deploy VPA app, and I will just quickly make it 2 and k get ports hyphen w. You can see there is one more container is getting run, and let's quickly verify this. What is the minimum request we get for this? So if you see here, the request came for 49 because in the configuration, right, what we have mentioned in the deployment is we have mentioned okay, started with the 10 milliseconds. But in order to start this with this, right, what will happen is it get the recommendation from the VPA and it is creating it as a 49 milliseconds of your particular pod. And you can see that the other pod was also started because this is just 45 seconds 17. uh, I'll show you. See, this was the pod which was just created when we initiate increased our replica, but this pod was there TZZLP, right? It was not there. The earlier pod was this one. It was terminated and it has created this one. If you describe this, it will also get a new request which is nothing, which is a 49 milliseconds. And what else we can do is we can see our describe VPA, and our VPA is this one. So here you can see that VPA updater evicted pod this to apply resources recommendation. You can check the events as well. So that's how that this VPA works, right? But this is something what it has done is it has recreated our pod. Like it has deleted my pod and recreated, and that brings some kind of downtime, right? And I don't want that. I want that okay, it will be on fly. Whatever the recommendation is there, that something is getting updated on fly inside a pod. How you can do that? Let's see. You can see, let delete this and then I will uh, create it again. 68-2. I have deleted it, right? And as of now we have this running. Let's delete this pod as well. 68-1. Now only we have load generator works, right? Let's create this again, which is 68-1 and key get ports, and you can see that this container is up and running now. And if I describe this key describe pod and VPA, you can see with the new configuration, it again came as a 10 milliseconds of your request, right? Now I want to be create this as a on fly. So for that we need to, okay, my system got disconnected, so I have connected it again, and we were discussing the VPA, where we want to see that how we can do it on fly without restarting our pod. So for that, what we need to do is we need to enable this feature inside our Cube API server, controller manager and scheduler. And then we need to tell our worker node as well that we have this feature enabled, so that it will try, right? Because if you see this, it is say in place recreate. So what does it mean is, when a pod is restarted, or maybe when the consumption get increased, it will VPA will try to modify that in place. If not, then obviously it will gonna recreate it. So we'll see what is that behavior, because it is not something that always it will gonna give you a in place, but we'll see whether in our case it will do it or not. So let's start with first these manifest file, and we need to update this feature. So I'll just copy this, and I will go to etc kubernetes manifest file. Here we have all these files, and I will go inside API server, and I will just simply paste this feature, and it will restart your what do you call that, API server, right? So we need to wait until it will come up. Meanwhile, we'll place all these thing in all file. Now we just need to update the scheduler as well, and it's done. Let's see. Yeah, because API server is getting restarted, so it will take some time. Meanwhile, let me just take node 1. This is the node 1 login. What is that password? Okay, we are in now. And now we need to go to file called var lib kubeconfig.yml, and I will go just in last line and will update this. Just do it. Okay, now it's good. Let's restart the kubelet, and we are done with the node. Let's check what is happening with our master node. And here also we are back. So let's check first replica, how many replica we have. Let's start with one, my VPA app. Yeah, it's good. Let's quickly create this, and it has done. Let's see, get pods. It is up and running. Now what we need to do is we need to create that VPA so that it will uh, verify that consumption of your pod, and based on that it will update the configuration, that request and limit for the CPU. So let this pod come up and then we'll start. Why it's not coming up? Let's see. uh, it should come up. Okay, now it's coming up. You can see that we have pod up and running. Now we'll configure this VPA. If we go to master node again, and I will just update that k create -f 68-3. Now it is created and it is consuming 25 M, right? Let's see if when I described it was coming with the 10 milliseconds of CPU, or you can say 10 millicore. Now if I describe the same again, it is still 10. It is still 10, right? Now let's deploy some virtual load and then we'll see whether it is getting increased or not. Okay, let's deploy some virtual load here. I will just simply copy this and I will cancel it. I will just generate this and I will generate one more. Now let's see what is happening to our VPA. Okay, so we have two load pods are running, which is getting some false load, and now this VPA app auto new, which is in place or recreate, we'll see what will happen. Whether it will replace your current running VPA request limit or it will recreate it. So that we need to see. Meanwhile, maybe we can just discuss these mode. I think we have already discussed, like we can put all these. But yeah, this is the difference between the HPA and VPA. So here you can see that what HPA does is it is increasing your ports and deployment in the replica set, whereas in vertical it adjusts your CPU and memory request and limit. Scaling direction, it is horizontal because the name suggests it is HPA, it is VPA, so obviously it is vertical. Both are depends on these metrics, and over time they just analyze and observe the stability of your environment, the consumption of your CPU, memory, and all this, and based on that it will take decision. The goal obviously maintain a high availability of your application so that it can maintain the target utilization and balance your load across all nodes or maybe pods. How it works, it is creating and deleting the ports to meet the workload demand, and it is just recommending and applying the resource changes inside a same pod. When scaling occurs, continuously adjustment during load changes, it is periodically after analyzing usage history. Now the pod restart, no, it will not restart the pod, rather it will simply delete that, terminate the current one and add the new one, like basis on the demand. If demand increases, obviously it will gonna add one or more, and if demand decreases, gradually it will remove the added ports. Here might get restart your pod, or maybe on the same pod it will get updated the request for CPU and memory or whatever the resources we are doing. Dependency, it has a depend on the metric server, and it requires a VPA component like recommender, updater, and admission controller, which we already set up in our environment. And this is a state useful for the stateless workload like web application APIs, and this is for the stateful where we have the long running workload which generally require a high CPU and memory. So these are the example use case. But before that, let's see what is happening to our okay, it haven't started. That's not good. So there is no workload. Okay, get VPA. It is still okay. Get ports and okay, get SVC. I think we are calling the correct SVC. It is VPA SVC. Let's see what we have done is we have done a VPA SVC as well. Okay, let's generate one more here and then we'll see. Load generator 3. and we'll see k get ports. We have up and running, and it is getting increased. Once that is increased, it will upload or it will change your this VPA configuration, and then you can see whether it is getting updated or not. Meanwhile, let me just describe it and let's see what is the value for CPU as of now. Okay, it's still 10 because it's not increased yet. Okay, get VPA. It's still 25 and it's keep on running. But why this VPA is not, the load is not getting increased? Okay, top ports. It is 47M, right? So it should be increased. But that is the recommendation for the VPA from that itself, right? And but we are using the 47M, so it must increase this VPA configuration. And then it will update the current working CPU request, or maybe it will regenerate it. Let's quickly create one more deployment. I just added and increase one replica here as well, because we don't have real workload, right? And we don't have that real workload and the consumption. So we cannot consider all these in a very high environment, right? And whatever the workload we are putting here, that is also not in on high nodes, high end nodes. Maybe the resources is less, so we need to see, adjust and all these things. But here it was saying minimum is 10, maximum is 200M, and this is the VPA configuration which is saying in place. What do you say that? Okay, we need to see here this node one I don't want. And if I'm gonna describe this second pod which we just deployed, it will come with the new value, which is maybe 25M. See, but it is not getting increased. Why it's not? Maybe k get ports hyphen n cube system metric server is up and running. Yeah, it should be k top pods. It's getting decreased because now what is happening is we have two workloads running, right? And that request is getting diverted, so that we can see now. Let me delete this pod and we'll see again. This I am gonna delete. And now if we'll see, we have only one workload. Okay, it is getting again created. Why? Because we have added the replica. So according to the deployment, if I just show you, it is 2 by 2. And if you delete it, obviously it will gonna recreate it again. But now you can see this 7M, I think we were checking earlier, right? Uh, DB. There is one thing happened, or maybe I will show you. K describe VPA and VPA auto new. If you see the event, it is saying that it has evicted this, right? VPA evicted pod this and apply resource recommendation. Now if you see, we have both pod. It is running 7h and ZR is just created again with the new recommendation, obviously because we have deleted one of the pod. But if you see this 7h, earlier the value was, because it is just recreated it again, right? So we'll not found that. But you can see it was evicted to FN, and in place of 2FN it is created a new one. Here you can see earlier it was running with the 10M, but now if I just show you, so instead of this, what it has done is it has created a this port again, and if you describe this, obviously it will come with the new value. So unfortunately it did not update our on fly, rather it has updated our what, a current running port, delete, terminated, and then deployed it again. But yeah, since I mentioned it is not a real environment or real workload, real load, real feature, so probably we can say that okay, it is not updating our workload on fly, right? That is why we cannot say. Let's see if it is allowing us a few more. But yeah, this is the concept which we just need to understand, okay, how it is exactly running. Because we need to update this API servers and everything to make that feature enable, so that API server knows, okay, now we have in place vertical pod autoscaler feature is true, and I need to try with the policy called in place or recreate. Then it will try to update first, if not then it will recreate it. So that's what the feature is. Okay, let it run and we'll see. Meanwhile we'll just finish our thing with the use case, where you can see that okay, whenever you have workload called web server and this one, right, then you, what you need to do is you need to consider this HPA. And if you have that another kind of workload, then you need to think of the VPA. If you are running a batch job or ML workload or changing the CPU needs very constantly, right, then you need to think of the VPA of your kind, your workload. If you are running a database, then also if you want to tune your memory or the CPU or the disk, right, then you need to search for the VPA configuration and you need to adjust your workload with the VPA configuration. If your API service where that you get the sudden spike, or maybe it is for the long hour it will keep on running, then you can think of the HPA where it will add more traffic or more ports to handle your traffic. So that was the use case for the HPA and VPA, right? So final takeaway from this course is always define CPU and memory request and limit in your deployment, right? Because that way it will be very easy for us to understand, okay, that was the minimum requirement, and now basis on the uses it has observed and recommended a new resource and limit. And whatever the type you are following, whether it's HPA or VPA, on the basis of it scaled your workload, right? So HPA always use when a load fluctuate, and VPA when you need a right size of your port. You can combine both as well to get the most efficient uses of your cluster. So that was the takeaway from this. I hope you found this helpful. Then please, I would request you to please subscribe and like my videos. I will be uploading more Kubernetes deep dive, hands-on, or maybe the other real-world explanation on the basis of all this VPA and HPA. But as of now, just to understand the basics of this, that is it for this. And let's check the final, and then probably we'll meet you in the next. Okay, it was never created, so that is the reason it is still running with the 2, and that was the recommendation of the 25M. right? Maybe I will create a very high worker node with some more high CPU and resources in our cloud, and then we'll try to do this hands on there, and then we'll see. All right. So yeah, that's it for the day, guys. I will meet you in the next video, where probably we'll start the Helm chart. What is Helm chart and how it can help with you in Kubernetes. All right. So that's it. Stay happy, stay learning. Thank you.